This research is about the prediction of the displacement mechanism of the cracked soil using nonlinear extended finite element method and artificial neural networking. The work is made based on the simulation and a validation result of the numerical simulation. Introduction. The crack initiation, propagation, crack interaction in each material, like a concrete, sandstone, steel, have a different mechanism. In the soil, without applying load or surcharge, due to the mechanical property of the clay soil, we have crack zone, which is initial crack is there. And the length of the crack in the crack zone is dependent on mechanical property of the soil. And when we applying load, a seismic load or a static load to the soil model, then crack will be extended and propagated. Objective of this research work is to simulate crack propagation and crack morphology based on the crack mechanical property and to realize the impact of the soil crack morphology on the displacement and vibration mechanism of the soil, which is leading to the collapse mechanism of the soil foundation. Methodology we have used here is shown in this picture. The first of all is to identify problem. The problem, what do you mean by identifying problem? Based on the mechanical property of the soil, length of the crack and crack zone and solid zone in the each model is different. When we modeled the soil, different part means solid zone and the crack zone, and we simulated the crack, then we going to run software which is nonlinear extended finite element method for prediction crack morphology, and the result assessment and validation will be based on the application of the artificial neural networking, and finally we predict a displacement and validation of the result. And if the result is the acceptable, then we stop simulation, otherwise we should back to the modeling. We have in the first picture of here at the top, we have a soil foundation is the crack zone and the solid zone. The crack zone is the identified based on the cohesive of the soil and density of the soil, and remaining whatever is there, it will be solid zone. In the second part, dimension of the soil foundation is shown in the meter. In this modeling, we use two soil, the soil A and soil B. The mechanical property for each soil are different. The data of the soil mechanical property have been collected from the literature, and here what we have, the acceleration in X, Y, and Z direction, simultaneously it was applying to the model. The result of this numerical simulation. In the first, we have the model 1. We use the soil type 1 or A. In that, we have a smaller crack length compared to the second model. And in before crack propagation in the model 1 and model 2, the differentiation is between in these two models is the length of the crack. But when we applying the seismic load on the model, what we have here, the movement of the crack or crack propagation. Not only movement of the crack, what will be speed of the crack extending and morphology of the crack is extending in each model are different. This mechanism of the crack propagation has important effect on a collapse or a failure of the soil foundation. Here, from the model 1, which we use a soil type OA, we want to show how the crack is propagating based on the result we have got from the numerical simulation. In the crack A, as we mentioned previously, the length of the crack is smaller. When we are applying the seismic load in multidirectional to this model, what will be happen? The crack is starting from here, and the crack is extended in the first step, second step, and third, and finally fourth. In the fourth step, we have here for the crack propagation and extension, and tip of the crack is the flexural crack of the in the second model. In the second model, what we have here is the figure of the second model. The length of the crack is bigger than model 1 is because of the mechanical property of the soil is changed. We use the soil type B because soil type B is more different in terms of the mechanical property. And now when we are applying the seismic acceleration in the multi-directional, the crack will be starting. This is the first step of the crack, and the second step, and fourth, and third, sorry. What we have, the tip of the speed of the crack is different, shape of the crack is different, and the morphology of the collapse is different from the model. What we have here in this picture, we have two models, model A and model first and model second. We use soil type A and B. What we have here, the displacement in X direction and the tip of the collapse. The soil type B, using the model 2, they showing more easing of the collapse of the displacement mechanism of the model 1 and model 2. This result we got based on the training and testing and validation of the result using artificial neural networking, how the is moving and displace. And here, if we check the model 1, the differential displacement is more compared to the model 2, because model 1 has more resistance against a seismic acceleration, and the collapse will be more later, and tip of the collapse is different. The result of a statistical analysis, we have here R and the MSE. In both is based on the R square and test, and for the training, test and validation, both we have MSE for the training, test and validation. The result are more acceptable, and based on this, their numerical solution has been validated. The conclusion, what we have here, the tensile displacement was main the factor for the soil failure, and lowest tensile strength of a model causes tensile displacement, and the initiation and propagation of the crack and vibration mechanism of the model have a direct relationship with the mechanical property of the soil. The morphology of crack governs the failure mechanism of the model, and the seismic acceleration transferring in a model. The speed and step of the crack propagation in each model have a specific characteristic and influencing the the vibration mechanism of the model, and the prediction of the crack propagation revealed the mixing soil technique is an appropriate soil foundation seismic design. Applying this model improve minimizing soil and earth structure failure. Thank you so much.